Subscribe to Mirza's Education and press on bell icon for every notification. Intersection of solid. This is the second part of the fourth unit, and in this topic we have two more topics, that is prism versus prism and cylinder versus cylinder. The problems are given here.
A vertical square prism base 50 mm side is completely penetrated by a horizontal square prism base 35 mm side. Okay, so that their axes intersect. The axis of the horizontal prism is parallel to the VP, while the faces of the two prisms are equally inclined to the VP. Okay, fine. Draw the projections of the solids as showing lines of intersections. Assume suitable lengths for the prism. Now, one thing that you should have seen is that the base edges are 50 mm, okay, of this vertical prism, and as far as this horizontal prism is concerned, the base edges are 35 mm long. All right, so let us write down initially what all data has been given to us. So one prism is the vertical prism, other one is the horizontal prism. One is having a base edge of 50 millimeters, other one is having a base edge of 35 millimeters, and in both the cases we're going to be assuming that the length or the height of the prism is going to be equal to 100 millimeters. All right, you can note that down. Now, how can the projection of this particular case be made? And as far as the solution of this particular problem is concerned, I've divided that into two different phases. In phase 1, we're going to be analyzing this object with the help of a virtual CAD model, and we'll be making an assessment as to how the front, top and side views can be made. And in the second phase, I'm going to tell you how the front, top and side views of this particular object can be done manually. Okay, I'll do that stuff on Autocad, but you can do that on a drawing sheet. Okay, so let's see how it goes. Okay guys, let's begin with phase number 1, and here you can see this virtual CAD model of the two penetrating prisms. So this one is the vertical prism and this over here is the horizontal prism. You can clearly see that this vertical prism is 50 mm base edged one, and this over here, this horizontal prism, is the 35 mm base edged square prism. Okay, so what basically we need to do is we need to create the front view, okay, something like this, and this is the line of intersection. Okay, this is the line of intersection. The surface of this, what do you call this, vertical prism is being intersected by the surface of this horizontal prism somewhere along a line, and this is exactly what we're going to be focusing on. Okay, so this is going to be the front view, this is going to be the top view, and finally let me show you how the side view would look, something like this. And all of this stuff I'm going to be doing on AutoCAD, and you guys can replicate the same on drawing sheet or even on AutoCAD. Okay, so let's see how all of that works out. Alright guys, now we're gonna draw and let's create the front, top and side views for this vertical prism. Now the first question that you should ask yourselves is from where you can see the true shape of the base. Okay, now this particular vertical square prism is having 4 corners at the bottom, A, B, C, D, and 4 corners at the top, that is in the form of E, F, G and H. Now the question is, from where can you see the true shape of the base? The answer is pretty simple, that it's going to be evident from the top, and hence we have to start by creating the top view first. Okay, something like this will happen. This is going to be the top view. Let me show you once again. Okay, this is what we need to do in the top view. Right now we're going to focus only on creating the top, front and side views of the vertical prism. Okay, so this is going to be the top view, only this much portion, and then there is going to be this front view, only this much portion. Please see where the mouse is hovering, only this much portion. All right, and then we're going to be creating its left hand side view also, only this much portion. Please see where the mouse is hovering. All right, now let's quickly get started with AutoCAD. So let me do this stuff. Let me make a point, and this is 50 mm. All right, yeah, pretty good. And let me do this once again. Oh snap, done. Again traveling a 50 mm distance. That's it. Now let me finish this with the help of this mirror command. You guys can continue to do this on a drawing sheet with the help of making arcs or so. Okay, so this is how the object looks from the top. All right, now we're going to look at this from the front, and for that I'm going to be projecting these lines from the bottom like this. Now this vertical prism in fact is having a height of, we are assuming that height to be equal to 100 millimeters. So what I'm going to be doing is I'm going to go 100 millimeters above, something like this, and that's it. I'm gonna be, let me do this again. Let me check if this is really 100 millimeters or not. No, something has gone wrong. Let me check this. 100 or not. Let me see. Yeah, that's 100. Okay. Let me erase this. Okay. Now let me copy this. Here. That's it. Now let me join. There you go. The front view done. All right. Let me darken this also. Okay, so right now we're going to be using a 4H pencil for this. If you're making this on a drawing sheet, make sure you're using a 4H pencil. And after the orthographic views of both horizontal as well as vertical prisms are done, and it is then that we're going to be looking for the piercing points or the lines along which the penetration is really happening. All right, now we are a long distance away from all those things to happen. Let's now focus on this front view is done, top view is done, and now let's create the side view. Okay, for creating the side view, we're gonna do this. Let me project these lines towards the right hand side. Done. Let me do this slightly downwards. There you go. Okay, now before moving forward, what I'm going to be doing is I'm going to be naming all these points. Okay, like you see, at the bottom we have 4 corners in the form of A, B, C, and D, and at the top we have again 4 corners, E, F, G, H. If you randomly speak of this particular corner, when you look at this from the top, you're going to have this point and this point, E comma A, and this is going to be F comma B, this is going to be G comma C, and this is going to be H comma D, I suppose. All right, so E comma A is going to be this E comma A. Okay, then this is going to be F comma B. All right, so this is going to be F comma B. Let's write down all those points quickly. All right guys, that's done. Now all these corresponding points are going to have their impact on the front view also. Like the base points are A, B, C. Okay, so this is going to be A dash, B dash, C dash, and just behind B we have D. Okay, so here we're gonna have B dash comma D dash, and similarly you're gonna have these points in the form of like E, F, and G, E dash, F dash, and G dash. So let's write them immediately. Okay, that's it. Now we're gonna move ahead to create its side view. All right, let me extend all these lines. Yeah, pretty good. Okay, let me produce lines from all these intersecting points in the upward direction, something like this. Okay, what's happening? Yeah, almost done. So the front, top, and side views have been created. I'm not going to do the numbering over here. You guys can do so. Now that we have successfully created the orthographic views for this vertical prism, we'll now go ahead and make the orthographic views, that is front, top, and side view for this horizontal prism, which is having a base edge of 35 millimeters. Now guys, you need to think about this, from where you can see the true shape of the base. Now this true shape of the base can only be seen from this side, that is from the left hand side. Okay, and hence we're going to start off by making its left hand side view initially, and then accordingly its front and top views can be made. Okay, fine. So let's go ahead and make this. For that, I'm going to do this simple construction. I'm going to be making a square yet again, something like this. Please watch. Okay, this is going to be 35 mm and at number 45. Okay, please keep on watching this. It's damn easy. And again, I'm using a mirror command. Yeah, good. And let's join the opposite corners with the help of these so-called lines. All right, now I'm going to be shifting this. Okay, I'm going to be shifting this. I'm going to be moving this rather. Let me copy this. Okay, copy this. Yeah, it's going to be located here, exactly at the center. Okay, so this is exactly how the penetration happens. Let me show you here. Yeah, that's exactly how it happens. Okay, front, and this is the side view, exactly at the center. All right, so the side view is done. We'll now go ahead and prepare its the top view, yeah, okay, and the front view. So let's see how this particular side view is going to have an impact on the top and front view. So let's do that quickly. And for that, what I'm going to be doing right now, you can actually number these points 1, 2, 3, 4. You can say that this is 1, 2, 3 and 4. You can do that. So I'm not gonna do that right now. I'm going to be shifting these points in the downward direction. Okay, let me rotate these points by an angle of 45 degrees. Let me do that quickly. Yeah, something like this. Let me extend these lines until we reach this vertical line over here. That's it. That's it. And now let me shift these lines somewhere here. Okay, at a random distance. All right. Okay. Now, what to do now? Something has to be done. Okay, randomly, I'm going to be drawing a line somewhere in the middle. Okay. Now, the horizontal prism that we do have here is having a length of, or an axis length of 100 millimeters. So I've taken this mid line, and towards the right we're going to draw 50 millimeter long line. Towards its left we're going to again draw 50 millimeter long line, so that the overall length works out as 100 millimeters. So let's do that. I'm going to start from here. This is going to be 50. All right, so I have drawn this line, and let me copy this line here, here, and let me copy this again. Let me show you. Please give me some time to do this. Here, here, and here. All right. Okay. Now let me finish this from here. From here to here, and let me trim this about this line, and it's gonna look something like this. Yeah, pretty good. All right, guys, so now that the front top view is done, we'll now go ahead and create its corresponding, what do you call it, front view. Okay, now this point over here, this is 1, 4. So when you try to look at this entire scenario from the top, this is going to be point 1. Here we'll have point 1. You look at this, you get 0.4, and just below 0.4 you have 0.2. Okay, so this is going to be 0.4, 2, and here we have 0.3. So this is going to be 0.3. Similarly, you can work out these points 8, 7, 6. Okay, 5, 6, 7, 8. So 5. So 5 is going to be somewhere here. Okay, then we have this 8, 6. All right, somewhere here 8, 6, and then finally we have this 0.7. So here we're going to write 0.7. Fine. So let's write that down immediately. Okay, now for creating the front view, you can see this line over here, this 37 edge. Okay, this is having a length of 100 millimeters. So what I'm going to be doing is, this is exactly at the center of this edge, appears apparently. Okay, so from here at the center, I'm going to go 50 steps along this direction, and then 50 steps towards the left. All right, so this point is what you call 0.3. This is going to be 0.7. Just behind 3 we have 0.1, and just behind 7 we have 0.5. You can write that down. Okay, but I'm going to be finishing off this. Let me do that. How can that be done? Let me bring in a reference line from here. Okay, and again a reference line from here. All right, and let me join this. Done. Again, let me do this stuff over to this side, and let me extend this in the downward direction. There you go. All right, so let us now fix in the points, and before that, let us trim this. So guys, be patient. It takes some time to explain the concept. And this is going to be 0.4. So this is 0.4. When you see this from the front, this is 0.3, and behind 0.3 we have 0.1. So this is going to be 0.3 dash comma 1 dash, and this over here is 2. So here we're going to write this as 2 dash. Similarly, you can work out these points over to this side. This is going to be 8 dash 7, and behind 7 we have 5, 7 dash comma 5 dash over here, and then we have the 6. So here we're going to write this as 6 dash. All right, let us write all those points, and it should look something like this. So all right guys, so that's exactly how it looks. We'll now go ahead and find the lines of intersection, okay, where the surfaces meet, or we're gonna rather find what you call the piercing points. Okay, so you can see this point, this is P1, this is P2. So when you look at this from the top, you're gonna have a piercing point in the form of P1. Just below P1 you're gonna have one more point, P3. Here we'll have P2, and behind somewhere here we'll have P4. Okay, so let's do that stuff quickly. P1, P2, P3 in the top view. It's gonna be somewhere, let me take this as a reference, P1. So this is gonna be point P1. Okay, please have a careful look. P1. In front we have this P2 and behind we have P4. So in front over here we have P2 and behind over here we have P4. Okay, and just below P1, this is P1, and below P1 we have P3. Okay, so we're gonna have this point as P1, and just below that P1 point we're gonna have one more piercing point, that is what you call P4. So let us write that immediately. Well, that's it guys. Okay, now just like we had these piercing points over to this side, similarly we're gonna have piercing points over to this side also, in the form of say Q1, Q2, Q3, Q4. Okay, here Q1, Q2, Q3, Q4. Okay, so this point very close to this edge 8, we have this Q1 8, we have this as Q1, this is going to be Q3. Below Q1 we have Q3, and Q1 and Q3 are going to be here. Okay, here we're going to be saying this as Q2, and this behind is going to be Q4. So let us write them down immediately. So alright guys, so that was all about the top view. We'll now go ahead and see the corresponding front views of all these piercing points. Okay, somewhere here. Alright, so let's see how they look. P2, let's see where P2 is. P2 and P4, one at the front, other at the back. So this particular point is for P2 comma P4 with a dash. Alright, now there is this point P1 and P3. So point P1 is going to be, let me show you here, this is one piercing point, this is going to be P1. So you can write this as P1, this is going to be P1, okay, over here. This is going to be P3, P3 is going to be here, and this is going to be P2, P2 is going to be here, and behind P2 you have one more point, piercing point, that is going to be P4. Okay, similarly over to this side you're going to have more piercing points like this. Okay, so this is going to be point, what do you call, Q2, and behind Q2 you have Q4. So this is going to be Q2 dash comma Q4 dash. Similarly, let us have one more piercing point. Let me extend this further. Okay, so here for Q2, please watch this carefully. Here there is Q2, and behind Q2 there is one more piercing point, that is Q4. So this particular point corresponds to Q2 dash. Okay, Q2, Q4, Q2 in the front, Q4 at the back, Q2 dash comma Q4 dash. So let's write all of these piercing points as front view in over here, that is in the front view. Alright guys, so these are the piercing points, and now in the next step we're going to be darkening the portion which is going to be visible to us. Okay, and for that I'm going to be using a dark colored pencil. You can use a edge pencil for this purpose. I'm going to be using a red colored one. Okay, so that you guys can have a better visualization for the entire scenario. Alright, now let's darken. Alright, there you go. Done, something like this. Okay, now what's next? From P1 to P2, okay, somewhere here, dark, okay, from here 3 to P2, dark. Alright, again from Q1, Q2, Q3, dark, Q1 dash, Q2 dash, Q3 dash. Again this much portion also has to be darkened from Q2 to 7. Okay, remaining portion, now the edge here, okay, some portion of this edge is falling exactly behind the face of this vertical prism. Alright, and that's not going to be visible, and hence you have to make use of a sort of a hidden line for that purpose. I'm going to be doing all that stuff. Just be patient for a while, and let's now build up. This edge is also going to be visible, so let's darken that also. Yeah, there you go. Alright, so what's next? Now let's go ahead and darken the top view. You can see the top view, it looks something like this, please. Something like this. Alright, yeah, pretty good. Yeah, that's it. That's it. Alright, so this is exactly how it looks from the top. Let me show you that once again. Exactly. And now few portions of the edges which are immediately falling below the square are not going to be visible, but we have to give them some respect in the form of hidden lines. I'm going to do that. Just wait. Okay, so this is all about the front view and top view. I'm not gonna do anything to the side view. You guys can do that stuff. It's pretty easy, or you can darken that. All right, let me do that. Let me finish that also. It's gonna look something like this. There you go. Not this way. That's it. That's the right way. Okay, we're almost done with a few modifications yet to be carried out in the form of hidden lines. Okay, now small portion from P1 to Q1 of this edge 48. Okay, it's not going to be visible, but we have to give it some respect in the form of creating a hidden lines. All right, from P1 to Q1. Okay, from P1 to Q1, we've got to make this line. So right now I'm going to be erasing this portion, and I'm going to be using a lighter line, a red color line in fact, but a different sort of a line, a hidden to one. Yeah, right. Let me erase this. Okay, let me erase this also, and this, just for a while, so that I can show you these so-called hidden lines from here to here, from here to here. That's it. And over to this portion also, you can see from P1 to Q1, you cannot see this. Okay, from P3 to Q3, from P3 to Q3, you cannot see this line. Let me erase this, let me erase this, and let me make use of a hidden line for this purpose. And here also, that's it. Let me erase this one, and again we're gonna use a hidden line, something like this. All right guys, so this is how you can develop the front, top and side view for two square prisms, one horizontal and the other one vertical, penetrating each other. Okay, making sure that the axes are bisecting also. So that's the solution. So guys, that was all from my side for today. If you have any doubts or queries, do write them down in the comment section below. I'll be very happy to answer them. I'll be taking up a few more problems based on cone cylinder intersection, or you can say cylinder cylinder intersection, pyramid and prism intersection. All these problems I'm going to be taking up in the upcoming weeks or so. Until then, it's a wrap. Of 80 mm diameter is completely penetrated by another cylinder of 60 mm diameter, their axes bisecting each other at right angles. Draw their projections showing curves of penetration, assuming the axis of the penetrating cylinder to be parallel to the VP. Assume suitable lengths for the cylinders. Alright, so there are two objects. One is a vertical cylinder, whereas the other one is a horizontal cylinder. Okay, now the lengths of these two cylinders, I'm going to assume it to be equal to 120 millimeters. You can note that down because that is something that I'm going to be using in my drawing. Alright, now the condition is the axis of the penetrating cylinder is parallel to the VP. Okay, so anything which is parallel to VP, you can say that its top view is going to be parallel to the XY line. Alright, now guys, I have divided this entire solution in two different parts. Part 1 is going to be all about analyzing the virtual CAD model, and I'm going to be showing you what that curve of penetration means. Okay, and in the second phase, or in the second part rather, we're going to draw. You're going to see the orthographic projection of these two penetrating cylinders. Alright, so let's see how all of that unfolds. So guys, this basically is the virtual CAD model of the entire scenario. You can clearly see a horizontal cylinder penetrating this vertical cylinder. Now this horizontal cylinder is having the base diameter of 60 millimeters, whereas this vertical cylinder is having a base diameter of 80 millimeters. Now when you try to look at this scenario from the front, you're going to see this. And this over here is the curve of penetration. Okay, the intersection between this vertical cylinder and this horizontal cylinder. Okay, the main challenge as far as this orthographic prediction is concerned is regarding this curve of penetration, and this is something that we're going to focus on. Okay, and when you try to look at this entire scenario from the top, this is exactly what you're going to see. Okay, this is the axis of what you call the horizontal cylinder. This is the axis of vertical cylinder. Both of them are bisecting each other, and this was the top view. And when you try to look at this from the side, it's going to look something like this. This is the left hand side view, to be very precise. Now guys, you can see that this is the curve of penetration, and I'm going to be positioning points over here in the form of say P1, P2, P3 and so on. Now let us say we have point P1 over here and let us say we have point P2. When you try to look at both these 2 points from the left hand side, they're going to appear as if they lie on the periphery of a circle. Please watch this. Okay, it appears as if P1 is over here, okay, on the periphery of the circle, and P3 is over here, although they are not. So we're going to be doing all this stuff. You guys can do that on Autocad. You guys can do that on a drawing sheet. I'm going to be showing you how all of this stuff can be carried out with the help of a PowerPoint presentation. So let's see how that works out. Alright, let's begin with part number 2 by drawing the orthographic prediction of this entire arrangement. So in order to do this, I'm going to be drawing 2 lines, okay, something like this, and this portion is what you call the vertical plane, and over here we have the horizontal plane, and this is the profile plane onto which basically what you call a side view is going to be made. Alright, let's go ahead and initially create the front, top and side views of this vertical cylinder. Now guys, just think about this. This is the vertical cylinder. Okay, now from where can you see the true shape of its base? Now one thing is for sure, that the base's true shape can only be seen from the top, and hence we're going to begin by making the top view first. Okay, now this circle is having a diameter of 80 millimeters. All right, we'll now proceed by making the front view, and it's going to look something like this. Okay, now this much height I've assumed to be equal to 120 millimeters, and this width is obviously equal to the diameter, that is 80 millimeters. Fine, let's go ahead and create the left hand side view. It's going to look something like this. Let us rotate that about this center. Okay, and let me get a vertical line in this direction. Let me get a horizontal line, and this intersection, okay, this rectangle in fact is again what you call the side view. All right, so the front, top and side view of this vertical cylinder is over. We'll now go ahead and create the projections, that is front, top and side again of this horizontal cylinder. Fine, for that you need to think, from where can you see the true shape of this base of this horizontal cylinder? Obviously, now one thing is for sure, that the true shape of this base, circular base in fact, can only be seen from the side, from this side, that is from the left hand side. All right, so what I'm going to be doing is, very specifically, I'm going to be placing a point. This is the center, exactly at the center of this line. Okay, I'll place a point, and with this guy as the center and with a diameter of 60 millimeters, that is equal to that of this horizontal cylinder, I'm going to be making a circle. All right, let me get rid of this point. Okay, I've divided this circle into 8 equal parts, and now with the help of this side view, I'm going to create the top view of this horizontal cylinder, and it's going to look something like this. Okay, project all these points with the help of these lines in the vertical downward direction, and then rotate them about this point, okay, in the clockwise sense, and then bring all the points towards the left hand side of this top view. Okay, and you can see from here to here, okay, the distance again I've assumed it to be equal to, or the length to be equal to 120 millimeters. So if you consider this to be the mid plane, towards the right of a mid plane you're going to go 60 steps, and towards the left of this mid plane you're going to go again 60 steps. So 60 towards the right, 60 towards the left, and that's the rectangle that you're going to get, which is having the entire length as 120 millimeters. Fine, so the side view and top is done. Now in the next step, we're going to go ahead and make the front view of the cylinder. It's damn easy. It's going to look something like this, right? Exactly at the center. Fine, something like this. All right, so this is going to be 120, and this is obviously equal to from here to here, and this is 60 millimeters, I suppose. Yeah, done. Now what shall be done now? We are going to focus on this curve of penetration, and that is our main focus of attention. Fine, so how can that be done? Okay guys, so please have a careful look at this. Please see where the mouse is hovering, this portion. Can you see this curve of penetration? Now this point corresponds to point P1. Okay, and when you try to look at this entire scenario from the left hand side, this curve of penetration would appear as a circle from the left hand side view. Okay, hence this point P1 is going to appear here, and there is going to be a point P2 over here. It's going to be lying here. This is P3, this is going to be P3 over here, P4, P5, P6, P7, and this is going to be P8. Fine, that's it. Just like we had all the points in the form of P over here, over to this side of this curve of penetration. Similarly, you're going to have one more curve of penetration at the back also over here, and in the form of Q. So behind P1 you're going to have Q1, behind P7 you have Q7, behind P3 you have Q3, and it's going to look something like this, right? Now these are all the points of penetration. Okay, so they're gonna be worked out from this side view over to this top view. Let us see how that can be done. Okay, so I'm gonna be shifting all these points over here. So this curve of penetration is for P and this curve of penetration is for Q. How can that be worked out? Please watch this carefully. We start from looking at this entire scenario from the top. You're going to see this point P1. It is far away from the vertical plane, from this XY line in fact. So this is going to be point P1. Now between P1 and P3 you have point P2 over here. So if this is P1, this is going to be point P2. Okay, P1, this is going to be point P2. Similarly, this is going to be P3, P4, and this is going to be P5. Let me write all of them down. Right. Okay. So, but along with this P2, why have I written P8? And along with this P3, why have I written P7? There is a specific reason behind this. When you try to look at this from the top, you're going to see point P3. P3, okay. Just below P3, you're going to have point P7. That's why I've written P7 also over here. Okay. Similarly, you're going to write P2 over here. And just below P2, you have point P8. So hence P2 with P8. Okay. Similarly, all the points over here to this side also can be worked out in this way. That's it. It's pretty easy. And now the only thing left is to have the curve of penetration in the front view. How can that be done? Well, the process is pretty simple. You're going to have vertical lines from all these points over to this side, something like this, and all the horizontal lines from the side view over to this side. Fine. The intersection of these two lines are going to give you the points of penetration. Now suppose you want to locate this point P3. So you're going to have two lines. One is going to be this one. This is the horizontal for P3, and this over here is the vertical for P3. Both of them are intersecting here. So this is going to be point P3 dash. Fine. Now if you want P1, P1 is here. Please watch this carefully. So this horizontal line is for point P1. And where is P1's vertical line? So this is P1's vertical line. So this is going to be point P1. Similarly, all the points, 8 points are going to be lying here and 8 points are going to be lying here. All of them can be worked out by this intersection policy, and it's going to look something like this. Okay, all points P over here and all points Q over here. And when you join all of these points, this is the intersection point, this is the intersection point, here, here, here. When you join all these points in proper sequence, you're going to get this curve of intersection, or what is popularly known as the curve of penetration. Okay, now let me darken the remaining portion. It's going to look something like this. There you go. Okay, the portion of cylinder which is inside, okay, from here to here also has to be given some respect in the form of a hidden line, and it should be starting from here, ending here, starting from here, ending here, and that's exactly how it looks from here to here, here to here. Okay, similarly, again there is going to be a hidden line in the top view also. Okay, let me darken this portion. All right, let us go ahead. Fine. From P1 to Q1, and just behind P1 we have this P5. From P5 to Q5, again this portion also needs to be darkened. That's it, guys. So guys, that was all about how the orthographic prediction of two penetrating cylinders can be prepared, can be constructed rather. I'll be back with more such videos on engineering drawing and some other subjects